"I've never seen anything like this," the plan checker told architect Peter DeMaria. "I can't approve what I don't understand." The drawings showed 6 shipping containers, rusted steel boxes from the port of Long Beach, stacked 2 stories high on a residential lot. The code had no provisions for containers as building elements. Critics predicted rust, structural failure, and neighborhood eyesore. 19 years later, the house stands without a crack in its welds. It survived every earthquake the region has produced. It won an American Institute of Architects Honor Award. It rents for $600 per hour as a film location. The code now has an entire section on container construction. This is how one architect rewrote the rules. The house stands 2 stories tall in a neighborhood of single-story tract homes, its walls made from the same corrugated steel boxes that crisscross the Pacific aboard cargo ships. 8 shipping containers stacked at angles, painted in neutral tones that catch the Southern California light. Inside, a 20-foot living room opens through glass airplane hangar doors onto a lap pool made from a buried container with its top cut off. The structure passed every building inspection the state of California could throw at it. It won an American Institute of Architects Honor Award for Design Excellence and Special Innovation. And 19 years after completion, it rents as a film location at $600 per hour. The building code that once had no category for what architect Peter DeMaria proposed now contains an entire section on intermodal shipping containers, provisions that exist in part because of what happened on this lot in Redondo Beach. But in late 2005, none of that had happened yet. The code said containers were prohibited. The architectural establishment called container construction an experiment, its practitioners mavericks. And a man who had spent 5 years researching an idea that professionals dismissed was about to bet his reputation on 6 rusted steel boxes that cost $2,000 each. The neighbors were watching. The building department had no roadmap. And everything Peter DeMaria believed about the future of architecture was about to be tested in the harshest regulatory environment in America. Peter DeMaria never intended to become an architect. Growing up in Madison, New Jersey, in an Italian-American family, he watched his older brother drag himself through architecture school, working until midnight while Peter attended artists' parties in New York. He enrolled at Keene University to study fine art and swore he would never follow his brother's path. Then a professor arranged a meeting that changed everything. Buckminster Fuller was 86 years old when DeMaria met him, still traveling the world to talk about geodesic domes and doing more with less. Fuller had spent decades arguing that humanity could solve its housing crisis through better engineering, not more money. That existing materials, properly understood, could shelter everyone on the planet. DeMaria walked out of that meeting with a different vision of what architecture could be. He completed his Master of Architecture at the University of Texas at Austin in 1986, moved to Los Angeles, and founded his own firm in 1992. For the next decade, he did what architects do, traditional residential work, one project at a time, each one custom designed from scratch. And each one cost too much. The problem gnawed at him. Southern California needed housing. Traditional construction ran $250 to $270 per square foot. A modest 3,000 square foot home cost $750,000 before the land, before the permits, before the landscaping. Working families couldn't afford what architects designed. The gap between what people needed and what the industry delivered kept widening. Around 2003, DeMaria took a sabbatical from his teaching position at Pasadena City College and spent a year traveling. He crossed the country and went abroad, studying every alternative building method he could find. Prefab systems, modular construction, repurposed industrial materials. He talked to builders and engineers and code officials. He measured costs and timelines and failure rates. By the end of that year, he had reached a conclusion. Containers were it, the most untapped resource in construction. The logic was compelling. A standard ISO shipping container is a steel box 8 feet wide, 8.5 feet tall, and either 20 or 40 feet long. It's engineered to stack 9 high while fully loaded, with each container rated to carry 57,000 pounds. The structure is inherently rigid, designed to survive Pacific typhoons, rough handling by crane operators, and the constant vibration of cross-country trucking. And America had millions of them sitting empty at ports. The trade imbalance with China meant containers arrived full and departed empty. They piled up at Long Beach and San Pedro, a surplus of industrial-grade steel selling for $2,000 to $3,000 each. The same amount of structural steel, purchased new, would cost 15 times as much. DeMaria saw what Fuller would have seen, a pre-engineered building component, manufactured to international standards, available for nearly nothing, strong enough to resist earthquakes in California's highest seismic zone. But no one had proven it could work. Not legally, not in a jurisdiction that enforced the Uniform Building Code. He spent the next 5 years in research and development. He studied how containers had been used overseas, in emergency housing, military installations, artist studios. He talked to structural engineers about seismic forces and connection points. He explored thermal insulation, because a steel box in the California sun would become an oven without intervention. By 2005, he believed he understood how to make it work. What he needed was a client willing to be first. Sven and Anna Perkel had been eyeing a lot in North Redondo Beach since 1998. The property spanned nearly 9,000 square feet, 5 blocks from the 405 freeway, backing up to an extra-wide alley. It was the kind of lot that could accommodate something unusual. Anna, an artist, had joked about building with shipping containers. When they finally began searching for an architect, they told DeMaria they wanted something eco-friendly, creative, low-maintenance, and affordable. They didn't mention containers, neither did he, at first. Then DeMaria laid out his proposal. A home built from recycled shipping containers, steel walls that wouldn't rot, wouldn't harbor termites, wouldn't burn. A structure engineered to shrug off the earthquake that would level the wood frame houses around it. The cost, roughly $125 per square foot, half what conventional custom construction would run. Anna Perkel looked at her husband. They not only wanted it, DeMaria later recalled, they were creative and bold enough to push the envelope with me. The gamble was enormous. DeMaria had never built a permitted container home. No one in California had. The building code didn't account for what he was proposing. The Perkels would be living in an experiment, or they would be living with the wreckage of one. They signed on anyway. But the building department didn't share their enthusiasm. The Redondo Beach Municipal Code was explicit. Storage containers, shipping containers, or other movable type containers were prohibited outside a building in any residential zone. The rule existed to prevent homeowners from dropping cargo boxes in their yards as makeshift storage sheds. It said nothing about incorporating containers into a fully permitted structure because no one had imagined anyone would try. Peter DeMaria walked into the building department with architectural drawings that showed 6 shipping containers cut and welded into 8 structural modules, stacked 2 high, wrapped in a thermal coating and connected by conventional wood and steel framing. It was unlike anything the plan checkers had ever seen. The Uniform Building Code had no provisions for shipping containers as building elements. There were no standard specifications, no approved engineering tables, no precedent to follow. Every material in the code, wood, concrete, steel framing, masonry, had decades of testing data behind it. Containers had none. A plan checker studied the drawings and shook his head. "I've never seen anything like this," he told DeMaria. "I can't approve what I don't understand." The American Institute of Architects, the professional organization that would later give DeMaria an award, had already weighed in on container construction nationally. Their assessment was guarded at best. Container architecture was mainly an experiment at this time, one report noted. Practitioners working with shipping containers were characterized as mavericks, a word that sounded romantic but meant, in practice, that the establishment didn't take them seriously. DeMaria knew politically it would jump up and bite us, he later admitted. The opposition wasn't just bureaucratic, it was logical. Containers are foreign-manufactured steel with unknown mill certifications. They've been exposed to salt spray, industrial chemicals, and years of hard use. They were never designed for human habitation. Critics pointed out that the coatings used to protect cargo might release toxic fumes, that rust would inevitably compromise the structure, that a building code existed precisely to prevent well-meaning architects from experimenting on homeowners. These were not unreasonable concerns. A family would live in this structure. They would sleep inside walls made from metal boxes that had spent years crossing oceans. If something went wrong, If the engineering calculations were off, if the thermal solution failed, if the whole thing collapsed in an earthquake, the Perkles would pay the price. DeMaria understood the skepticism. He'd heard versions of it for years. "It's going to fall down," critics said. "It's going to rust away. It'll look like a freight yard." He had answers for the technical objections. The containers would be sandblasted, inspected for structural damage, and repainted with industrial coatings. Mill certifications could be obtained through American testing labs. The thermal coating came from NASA, a ceramic compound developed for the Space Shuttle's heat tiles, capable of blocking over 95% of solar heat before it entered the walls. But having answers wasn't the same as having approval. The building department couldn't simply waive the code. They needed a pathway that demonstrated equivalency in life safety and fire protection. DeMaria would have to prove, with engineering calculations and material certifications and structural analysis, that his unconventional approach met the intent of every provision his containers couldn't literally satisfy. He had anticipated this. "When we do a project," DeMaria explained, "we do a feasibility study right from the get-go. We answer all their questions in advance. They say, wow, the building department doesn't have to hold our hand. We can actually hold their hand in the project because we're well versed in it." He compiled comprehensive documentation, structural engineering calculations showing how the connected containers would resist seismic forces, material specifications for every coating and fastener, fire testing data for the thermal barrier, load diagrams demonstrating that the container walls exceeded what the code required for conventional construction. The package was overwhelming by design. DeMaria wanted officials to see that he had thought through every objection before they raised it. Still, the process dragged. Special approvals were required for the use of recycled materials. Each unusual element triggered additional review. The Perkles had hoped to be living in their new house by now, reported the Los Angeles Times in late 2006, but delays in obtaining permits and in construction have pushed their move-in date. They had already sold their previous home. Their belongings sat in storage, in a shipping container, as it happened. So, they were living in limbo while the city debated whether their future home was legal. The professional architecture world offered little support. DeMaria's approach blended product design and industrial materials in ways that didn't fit academic categories. He faced opposition from the professional and academic world of architecture, he acknowledged, for his unconventional methods. The vision that had inspired him, Buckminster Fuller's dream of doing more with less, of architecture as a repeatable product rather than a one-off luxury, I'd put him at odds with an industry built on custom design and billable hours. Every week that passed without approval was a week the Perkles paid carrying costs on a lot with no house on it. A week DeMaria's reputation hung on a project that might never be built. A week the skeptics could point to the empty lot as proof that this maverick idea didn't work. But DeMaria kept pushing, and slowly, one approval at a time, the building department found pathways to yes. The containers arrived in November of 2006. They came from the port at Long Beach, 6 ISO high cube units, the tall version, with 9.5 feet of interior height instead of the standard 8.5. They were weathered and dented, showing their years of service in rust-brown patches and scraped paint. To the neighbors watching from their single-story tract homes, it looked like someone had dropped a freight yard into a residential lot. This was the moment DeMaria had prepared for. The containers went first to an off-site fabrication shop, not to the Redondo Beach lot. There, workers sandblasted the exteriors, removing years of oxidation and contamination. They cut openings for windows and doors using plasma torches. They reinforced the cut edges with steel framing to maintain structural integrity. A container's strength lies in its corners and edges, and every penetration had to be carefully engineered. 6 original containers became 8 structural modules of varying sizes. Some kept their full 40-foot length. Others were sectioned into smaller units that would stack and interlock at different angles. The welding had to be precise. Once these modules were connected on site, they would function as a single rigid structure. DeMaria's plan called for 70% of the building to be assembled off-site. This was deliberate. Traditional construction spreads disruption across months, trucks arriving daily, workers on site from dawn, debris and noise and dust accumulating. The container approach concentrated the heavy fabrication in an industrial facility where noise and sparks were expected. The residential lot would see only the final assembly. While the containers were being modified, crews prepared the foundation. The site required excavation for a subterranean 3-car garage, unusual for Redondo Beach, where most homes sat at grade. Embedded steel reinforcements would anchor the container modules once they arrived. The foundation work was conventional, the kind of thing plan checkers understood. It bought time while the unconventional elements came together elsewhere. The thermal solution was the piece that made everything else possible. A steel container in the Southern California sun absorbs heat like a radiator. Without intervention, interior temperatures would become unbearable within hours. Traditional insulation, fiberglass bats, spray foam could work, but it would eat into the already limited interior width and require extensive framing. DeMaria had found something different. Supertherm was a ceramic-based coating manufactured in Kansas by a company called Superior Products International. Its origins traced to NASA. The founder, Joseph Pritchett, had contacted NASA's Marshall Space Flight Center in the 1980s, seeking compounds that could block heat transfer. The space agency provided lists of ceramic materials used in the space shuttle's thermal protection system. Pritchett spent 6 years testing combinations until he arrived at a formula that could be applied as a thin liquid coating. The product contained 4 ceramic compounds tuned to block 3 forms of solar radiation: visible light, ultraviolet, and infrared. Unlike conventional insulation, which slowed heat after it penetrated a surface, Supertherm prevented heat from loading onto the surface in the first place. The manufacturer claimed it blocked over 95% of solar heat, with a total reflectance rating of 96.1%. Applied at a thickness of 10 mils, roughly the width of a credit card, it added virtually no dimension to the walls. It carried a Class A fire rating with 0 smoke and 0 flame spread. It resisted mold and mildew at 9 out of 10 on the standard test scale. Crews sprayed Supertherm on both the interior and exterior surfaces of every container wall, ceiling, and floor. The coating went on like paint and dried to a ceramic shell. If the manufacturer's claims held, the steel boxes would stay cool without air conditioning, relying on passive solar design and natural ventilation, but ceramic insulating paints remained controversial in the building science community. The Environmental Protection Agency did not recommend them as replacements for traditional bulk insulation. Cold climate tests had found no measurable benefit. DeMaria was betting that the warm climate application, blocking solar heat rather than retaining interior warmth, would perform as advertised. For the wood-framed sections of the house, he added a backup: ultra-touch insulation made from recycled denim. If the ceramic coating underperformed, the conventional insulation would carry the load. By late 2006, the modified containers were ready for transport. The fabrication shop had transformed freight yard cast-offs into precision-engineered building components. Each module had been measured, reinforced, coated, and fitted with connection points that would align with the others on site. The crane arrived on a morning when the neighbors had plenty of time to watch. 8 modules swinging through the air, one by one, lowered onto a foundation that looked almost conventional until the steel boxes touched down. The crane operator worked slowly, positioning each piece according to DeMaria's drawings. The modules stacked too high, rotated at angles that created visual interest and structural bracing. Workers welded the connection points, top and bottom, corner to corner, until the 8 separate pieces became one continuous steel frame. What the neighbors saw was a house that looked nothing like the houses around it. Corrugated metal walls, industrial proportions, angles that belonged on a freeway, not a residential street. A standout in a suburban neighborhood of single-story tract houses and recently remodeled 2-story homes, as one observer described it. What DeMaria saw was a structure that would survive forces that would level every wood frame house on the block. The connected containers formed, in engineering terms, a big steel box. The inherent rigidity of the welded connections meant seismic forces would transfer through the entire structure rather than concentrating at weak points. Each container was rated to carry 57,000 pounds, stacked 9 high on a rolling ship. Connected and anchored to a reinforced foundation, they created a lateral resistance that far exceeded code requirements. The living room's airplane hangar doors, actual aviation hardware repurposed for residential use, cost $17,500 for 2 units. Equivalent residential custom doors would have run $70,000. Over and over again, DeMaria explained, we're taking materials from other industries, reinterpreting or reapplying them to this scenario, and we come up with a reinvigorated thing. The pool went into a container buried in the backyard, its top removed to create a 30-foot lap lane. The subterranean garage took shape beneath the main structure. Interior framing began defining the spaces that would become 4 bedrooms, 3.5 bathrooms, an artist's studio, an office, and a gym. By spring of 2007, the house was taking recognizable form. The Perkles could walk through what would become their living room, look up at the 20-foot ceiling, and see their vision becoming real, but the skeptics were still watching, and nothing had been proven yet. The structure was complete on paper. It had passed structural inspections, fire inspections, every checkpoint the building department required. The engineering calculations said it would work. The manufacturer's specifications said the thermal coating would perform. Peter DeMaria's 5 years of research said container construction was sound. None of that meant anything until the house was occupied, until it faced its first earthquake, its first summer heat wave, its first winter storm. Until the Perkles lived inside those steel walls and discovered whether the promises held up. The final inspection was scheduled. If it passed, the Perkles would move in. If anything had been missed, a welding flaw, a ventilation problem, a code violation no one had caught, the delays would continue. The critics would have new ammunition. The experiment would remain an experiment. DeMaria had answered every question the building department could think of. He had documentation for every material, calculations for every load, certifications for every coating. He had done everything possible to control the outcome. But the building officials had the final word, and they had never approved anything like this. The inspector arrived with a clipboard and walked through the structure that regulations had never anticipated. The steel walls, the ceramic coating, the repurposed aviation doors, the buried container pool. Everything Peter DeMaria believed about the future of architecture, that industrial materials could be beautiful, that recycled components could outperform virgin construction, that housing could be a product instead of a luxury, hung on what happened next. The inspector moved through each room methodically. He checked electrical connections against the approved plans. He verified that fire-rated assemblies matched the specifications. He tested smoke detectors and examined the seismic anchoring at every connection point where container met container, where steel met foundation. The inspection took hours. DeMaria had prepared for this moment for 5 years. He had walked other inspectors through the logic of container construction, answered their questions before they asked them, provided documentation so thorough that officials said they could hold his hand instead of the other way around. But preparation didn't eliminate the uncertainty. Every unconventional choice, the recycled steel, the ceramic coating, the aviation doors, the buried pool, represented a departure from what inspectors knew and trusted. The Perkles waited. They had sold their previous home. Their belongings sat in storage. Their finances were tied up in a lot, and a structure that couldn't be occupied until this man with a clipboard said yes. The inspector finished his walkthrough. He made notes. He compared what he saw against the approved plans, against the engineering calculations, against the code provisions that DeMaria had satisfied through alternate means and methods rather than conventional compliance. Then he signed off. In May of 2007, the Redondo Beach shipping container house received its certificate of occupancy. The first 2-story container home in the United States to fully comply with the Uniform Building Code in earthquake-prone Southern California was officially legal. The Perkles moved in. But passing an inspection wasn't the same as proving the concept. The building department had certified that the structure met code requirements on paper. What no one could certify was whether it would actually work, whether the thermal coating would keep the interior comfortable without air conditioning, whether the steel walls would hold up to coastal salt air, whether the welds would survive the next earthquake. The real test wasn't a single dramatic event. It was time. The first summer arrived with the relentless heat that Southern California residents know well. Temperatures climbed into the 90s, and the sun beat down on the corrugated steel walls that critics had warned would turn the house into an oven. The Perkles didn't install air conditioning. The design didn't require it. The supertherm coating performed as DeMaria had calculated. The ceramic compounds blocked solar radiation before it could load onto the steel surfaces. The interior temperature stayed stable, while conventional homes around them ran their HVAC systems at full capacity. The airplane hangar doors opened the living room to cross-ventilation, pulling ocean breezes through the space. No utility bills from the property have been publicly released, so precise energy savings can't be documented. But the Perkles lived in the house through summer after summer without adding mechanical cooling. The design theory held up in practice. The coastal environment posed its own challenges. Redondo Beach sits in the salt air zone where marine humidity accelerates corrosion. Wood frame homes in the area require constant maintenance, repainting, resealing, replacing components that rot in the damp air. The skeptics had predicted that the container walls would rust away, that corrosion would compromise the structure within years. The industrial coatings told a different story. The containers had been sandblasted and refinished with automotive-grade acrylic paint over the ceramic thermal layer. The same coatings that protect cars from coastal corrosion protected the house. Years passed without visible rust, without structural degradation, without the maintenance cycle that consumed neighbors' time and money. Termites were another matter entirely. Subterranean termites infest Southern California in densities that destroy wood frame homes from the inside out. Homeowners spend thousands on inspections, treatments, and repairs. The damage is often invisible until structural failure reveals the extent of the infestation. Steel doesn't interest termites. The container walls offered nothing for them to consume. While neighbors fumigated and replaced damaged framing, the Perkles' home remained immune to an endemic threat that cost California homeowners billions of dollars annually. Then came the earthquakes. Southern California experiences hundreds of seismic events each year, most too small to notice. Occasionally, larger quakes test structures throughout the region. The Perkles' home sat in the highest seismic design category, built to withstand forces that would collapse inadequately engineered buildings. The connected container modules functioned exactly as DeMaria's calculations predicted. The welded steel connections transferred seismic forces through the entire structure rather than concentrating stress at weak points. The inherent rigidity of the box-within-a-box design, containers originally engineered to survive Pacific typhoons while stacked 9 high, provided lateral resistance that far exceeded residential code minimums. No damage was ever reported, no cracks appeared in the welds, no structural assessments found problems. Earthquake after earthquake passed through the region, and the container house absorbed them without incident. 5 years after moving in, Sven Perkel gave an interview to Bob Vila's website. "We've been living in the house for 5 years," Perkel said, "and we're still very happy." The statement was simple. It was also devastating to everyone who had predicted failure. 5 years of California sun hadn't baked the interior into an oven. 5 years of salt air hadn't rusted the walls. 5 years of seismic activity hadn't cracked the wells or shifted the foundation. 5 years of termite pressure hadn't compromised anything because there was nothing to compromise. The experiment wasn't an experiment anymore. It was a home that worked. Professional recognition came quickly once the results were undeniable. In 2007, the same year the house was completed, the South Bay and Long Beach chapter of the American Institute of Architects awarded DeMaria an honor award for design excellence and special innovation. The organization that had called container construction mainly an experiment recognized that this particular experiment had succeeded. The award carried weight. The AIA doesn't give innovation awards to projects that merely look interesting. The recognition meant that credentialed professionals, the same establishment that had viewed container architects as mavericks, acknowledged DeMaria had achieved something significant. Media coverage spread far beyond the architecture press. CNN featured the project, bringing container construction to a national audience that had never considered industrial shipping boxes as building materials. ABC News ran multiple stories, including detailed interviews with DeMaria and the Perkles that documented the construction process and the home's performance. The Los Angeles Times had tracked the project from the permit struggles through completion. The Sundance Channel included DeMaria's work in Big Ideas for a Small Planet, a 2008 series about sustainable innovation. This new house, produced by TOH Productions, featured the home in 2010. Inside Edition covered it. Wired Science covered it. In 2009, Lexus built an entire advertising campaign around DeMaria's work. The power of hybrid innovation, used his container architecture as the centerpiece example of forward-thinking design. A car company selling hybrid vehicles to environmentally conscious consumers chose a house made from recycled freight containers as the image of the future. The project appeared in at least 15 architecture and design books published across 6 countries. Container Atlas from Gestalten Press in Germany, New Container Architecture from Links International in Spain, Prefab Houses Design Source from HarperCollins, Living West, New Residential Architecture in Southern California from Monticelli Press, Dream Homes of Los Angeles from Panache Publishing. DeMaria's work was exhibited at the A+D Museum of Los Angeles, at UCLA, at SCI Arc, the most prestigious architecture institutions on the West Coast. Mother Nature Network called it the definitive shipping container trophy home. The recognition addressed the core objection that skeptics had raised. Container homes weren't supposed to be beautiful. They weren't supposed to win design awards or appear in coffee table books about dream homes. They were supposed to look like freight yards, like emergency shelters, like desperation housing for people who couldn't afford anything better. The Redondo Beach House looked like none of those things. It looked like architecture, intentional, confident, distinctive architecture that happened to be made from recycled industrial materials at half the cost of conventional construction. The skeptics who had warned of rust and ugliness and structural failure had 3 choices: acknowledge they were wrong, pretend they had never objected, or dig in despite the evidence. Most chose silence. The documented record contains no follow-up quotes from early critics explaining how they had been mistaken, no public recantations from officials who had delayed the permits, no admissions from architects who had dismissed the approach. The absence of criticism became its own form of validation. When the people who predicted failure stopped predicting failure, the prediction has been answered. Some skeptics remained unmoved. A commenter on a later DeMaria container project captured the persistent resistance. The home belongs in a Wilmington storage area or a railroad siding, not in a single-family neighborhood. The objection had shifted from structural concerns to aesthetic preferences, a retreat from falsifiable claims about performance to unfalsifiable claims about taste. DeMaria didn't gloat. He didn't issue statements mocking his critics. He had a different response to vindication. He built another one. The Redondo Beach House proved that container construction could be permitted, could be beautiful, could perform as well or better than conventional methods in every measurable dimension. DeMaria's next step was to prove it could scale. In 2008, he founded Logical Homes, LLC, with the explicit goal of turning container architecture from a one-off experiment into a repeatable product. The company launched its Aegean 640 model Ashane, a prefabricated container home designed for mass production, at the Consumer Electronics Show in Las Vegas. 25,000 website inquiries arrived in the first year. The demand validated what DeMaria had believed since his year-long sabbatical studying alternative construction. People wanted affordable, sustainable housing. They wanted something different from the wood frame boxes that developers mass-produced. They wanted what the Redondo Beach House represented: quality architecture at a price that didn't require a lifetime of mortgage payments. Logical Homes offered homes starting around $75,000 for the basic models, a fraction of conventional custom construction. The company couldn't build fast enough to meet demand. The 2008 financial crisis complicated everything, but the interest never faded. DeMaria continued designing individual container projects, a home in Venice Beach, another in Long Beach. Each one refined the techniques, expanded the possibilities, demonstrated new applications. In 2017, he completed a second container home in Redondo Beach itself, a duplex for the Dowd family, built from 14 shipping containers. The city that had once lacked any code provisions for container construction now processed the permits without drama. The pathway DeMaria had pioneered had become a recognized option. The industry he helped create expanded far beyond his individual projects. Fortune Business Insights estimates the global container home market at over $60 billion, with projected growth of 5 to 6.5% annually through the early 2030s. Companies like SG Blocks, Honomobo, and dozens of smaller builders compete for customers who want what DeMaria demonstrated was possible. Container architecture has become its own category, with specialized engineers, dedicated fabricators, and established permitting procedures. The California Building Code now contains Section 3115, which provides detailed provisions for intermodal shipping containers as building elements. The section covers data plate requirements, structural design procedures, and allowable shear values, the technical specifications that inspectors need to evaluate container projects. None of these provisions existed when DeMaria walked into the Redondo Beach Building Department in 2005. The code changed because projects like his proved the concept. Regulatory frameworks followed demonstrated success. Once enough container homes stood without falling down, once enough inspectors had approved them using alternate methods and means, the building code incorporated what had become established practice. DeMaria's career evolved beyond single-family homes. He recognized that the same principles, prefabrication, recycled materials, industrial efficiency, could address housing problems far larger than wealthy clients seeking distinctive architecture. The housing crisis that had bothered him since his days of traditional practice hadn't improved. If anything, it had worsened. Through partnerships with HBG Steel and fashion executive Max Azria's Azria Homes, he developed factory-outsourced modular construction at scale. His team produced the first China-outsourced single-family home approved by California's Housing and Community Development Agency, a regulatory achievement that opened new possibilities for cost reduction through international manufacturing. The work led to Hope on Lafayette, Hope on Western, and Hope on Alvarado, bridge housing and affordable housing projects in Los Angeles, specifically designed to address homelessness. These weren't showcase homes for architecture magazines. They were emergency housing units built fast enough and cheap enough to get people off the streets. The projects earned their own recognition, an American Institute of Steel Construction Award in 2022, Modular Building Institute recognition in 2023, additional AIA awards for work that fulfilled the social mission DeMaria had articulated since his meeting with Buckminster Fuller. In 2023, he co-founded Mid-Rise Modular LLC with partner Diego Rivera. The company focuses on 5-story plus non-combustible modular construction from a 100,000 square foot factory. The scale is industrial. The goal is the same as it always was: housing as a product, not a luxury. He also co-created Team Prefab in 2020, a global database connecting prefab industry professionals. The network that didn't exist when he started researching containers now has infrastructure to support builders worldwide. The house that started it all still stands in Redondo Beach. 19 years after completion, the Perkles still own the property. They've maintained it, lived in it, raised their family in it. The steel walls haven't rusted. The thermal coating still blocks the summer sun. The welds have survived every earthquake the region has produced. The home also earns income. It's listed on Gigster as a filming and photo shoot location at $600 per hour with a 4-hour minimum. The listing shows a 4.81 out of 5 rating from productions that have used the space. The owner is identified as Sven P. The structure that the building code couldn't categorize, that skeptics said would rust and collapse, that the architecture establishment dismissed as an experiment, that structure is now a rental property commanding premium rates because of its distinctive appearance. The experiment became an asset. Peter DeMaria stood in a meeting room in 1982 and listened to Buckminster Fuller talk about doing more with less, about the possibility that humanity's housing crisis wasn't a problem of resources but a problem of imagination, about building components that already existed, waiting to be recognized. 25 years later, he stacked 6 recycled steel boxes on a lot in Redondo Beach and proved that the vision was real. The containers cost $2,000 each. The total construction ran about $125 per square foot. The home that resulted has outlasted the predictions of every skeptic who said it couldn't work, won awards from the organizations that doubted it, appeared in books published on 3 continents, and inspired an industry now valued at $60 billion. The building code has a section for intermodal shipping containers now. The pathway that DeMaria had to invent is documented in black and white, available to any architect willing to follow it. The Maverick approach became standard practice. If you drive through Redondo Beach today, past the single-story tract homes and the recently remodeled 2 stories, you can still find the house that didn't fit. corrugated steel walls at angles that catch the California light, airplane hangar doors opening onto a pool made from a buried container, a structure that looks like nothing else on the block because it was never trying to look like anything else. The neighbors stopped watching years ago. The building department moved on to other projects. The critics who predicted failure found other things to criticize. What remains is the house itself. Steel and ceramic and glass, standing exactly where Peter DeMaria said it would stand, performing exactly as he said it would perform, worth exactly what he said unconventional thinking could be worth when the world stopped laughing long enough to look at the results. The man who swore he'd never be an architect built something that changed what architecture could mean. The clients who joked about shipping containers raised their family inside one. The building code that prohibited movable containers in residential zones now explains how to permit them properly. And somewhere in a 100,000 square foot factory, the next generation of modular housing units is taking shape. Descendants of an idea that started with rusted steel boxes and a belief that everyone deserves a home. The neighbors don't laugh at container houses anymore. Not in Redondo Beach, not anywhere the evidence has reached. They're too busy asking how to build one.